Alright, quiz rigid body kinematics, quiz number 5. Question asks, a disk oscillates about its axis of rotation given by its angular acceleration of alpha equals negative k theta. First determine the value of k for which omega angular velocity equals 14 rads per second when theta equals 0, and when theta equals 6 radians, and theta equals 6 radians when omega angular velocity equals 0. Then determine the angular velocity when theta equals 1.4 radians. Input your answer with 1 decimal places and make sure it is positive. So start out by drawing our free body diagram, because it's free. And we went ahead and identified our knowns. Our alpha equals negative k theta, and omega equals 14 rads per second at theta equals 0, and omega equals 0 at theta equals 6 rads. So we need to find the value of k. We need to find the value of k and then find the value of omega when theta equals 1.4 rads at theta equals 0, alpha equals 0. So first off, we have the relationship between alpha, omega, and theta, which omega is the time derivative of alpha, and theta is the double time derivative of omega. And then we also have the equation: our angular velocity equals our angular acceleration equals our angular velocity, and that equals negative k theta. Negative k theta. So we went ahead and organized. So we got rid of the alpha and then reorganized our dw and our d theta so we can have an integral. We went ahead and solved the integral all the way down until we got k equals 5.4. And seeing as that is just a constant and not actually a value, there aren't any units on it. So we have our alpha equals negative 5.4 theta. So we need to find our omega at theta equals 1.4 rads. So we'll go ahead and do the same. Well, actually, we'll just take the original equation, this one right here, and then just skip down to here. We have our using our equation over here that our omega is the time derivative of alpha. So alpha is so if you integrate alpha, you get omega. So we took the integral of alpha, which turns into omega, and then the integral of negative 5.4 theta in regards to theta, and that's between 0 and 1.4 rads. We didn't really specify a starting point, but I'm just going to assume that our starting point is theta equals 0 and not omega equals 0 or anything. Theta equals 0. So it went from theta equals 0 to theta equals 1.4 rads. Our omega equals negative 5.4 over 2 times 1.4 squared, and the rads per second is negative, but seeing as you can kind of put it either way, omega equals 5.3 rads per second.